Okay, let's move on. If you don't have this testing resident model test, you don't have that data, you don't have that facility. The problem is that when you are designing a pavement for with ASHTO method, you require MR. They are not going to gain, you cannot take input the value of CBR. So what you do? And this is, you know, this test was developed in US. So, and people know that most of the countries around the world, even with most of the states in US, they don't have this resident model testing machine at that time. So people have uh, gone with lot of research and they try to find the best relation so that if someone has the CBR value, he or she may have the resident model. Uh, but even whatever relation you have, it is again an approximation. In the field of engineering, actual results cannot replace the empirical results. So most of the time, uh, it helps you. But again, if you are interested in finding the exact value, you must perform the actual resident voltage test. So there is no direct correlation because CBR and resident voltage, as I explained earlier, they are very different in terms of measuring the mobility of the testing protocols. And whatever is being presented here, they are based on limited data. So what is uh, up to 1993 or 1998, people used to use this relation while designing a paper. That is, MR is 1500 times the CBR value. Now, it must be noted here and must be, remember that even though CBR value is taken as percentage, in all the calculation we perform, we don't consider percentage. For instance, if I say I mean CBR 10, actually it is not 10, it's 0.10. But with MR relation, we consider 10. We don't divide it by 100. So if it is CBR 5, while you want to convert it into MR, just don't say this 0.05, it's 5. So actually, if it is CBR 5 from this relation, 1500 into 7500. So actually, this relation was developed in 1962. And believe me, most of the people now in the industry also are still using this thing, 1500 CBR. But the problem is, if you have say soil having CBR 50, then you cannot apply this relation. Again, people are using this relation. People were using this relation because this relation was not developed for all range of soil. So in uh, National Cooperative Highway Research Project, while developing a mechanistic design guide, they have come up with a relation, and it's a very true relation that you have to multiply. Actually, you have to multiply 2555 times CBR having exponent 0.64. So what you do, you take the value 0.64 power of your CBR value multiplied by 2.5, and it is not limited to any soil. It is limited to all type of soil. So The previous equation that was developed in 1962, it's now you can say it's become dormant. And this is the best approximation people have come up with 2555 CBR, for example. And allow me to say that 1500 CBR is now not very much used, and it's very rare that people use this formula. So what you do instead of having resident model tests with all those sophistication and all those things, perform the CBR. And whatever is that CBR value, use this relation that is in the red box like that. Other than that, people have also done some other relation. For example, they say the sand has having a CBR value of 31, have this resilient modulus 46,500. And then, that was developed by in 1982 in which Asphalt Institute, there is another research institute that have developed this relation. So this is nothing to do with 1500 CBR or 2555. Because people at different times have experimented with these samples, they have come up with those values. So this is another way. If it is silt, 30,000 psi, if it is in heavy clay, it is 7,800. And people have also come up with triaxial test value, and you can imagine that these are all different. They have some other parameters that has been taken along. So to come up with this thing, any soil that has CBR value of 70, they are regarded as a very good soil, A1 soil. Or if you don't know, even if you don't have this CBR test facility, and just classify the soil using H2 method or USC method, you can estimate that if you have A1 soil, its PVR must be greater than 10. If you have 80 soil, this is 20 to 70. If this you have an A4, A5 soil, you see a CBR 5 to 20. And very poor soil. Over the years, must have been done by the scientists, and they have tried to educate people. So the people are not only just confined themselves, oh, we cannot do CBR test, we can do it. But you can have those correlations. But the thing is, whenever you use these relations, must reference it. It's very important. Then comes another relation. So I use this relation very much. It's because people seldom do first is if there is in the boundary wall there are buildings, and those buildings are to be connected to the road. So generally what the people do, they test their soil for bearing capacity, load bearing capacity, right? They do not test it for CBR. So comes to you that so people say, okay, I'm designing the road in this locality, it has got 0.5 ton per square foot soil. So if you know this thing, you don't have, the one thing is, you say, I'm not going to design your pavement. Go and get the CBR value. This is very rude to us. This is very rude to some people. Because a common man is not a transportation man. He's not a pavement engineer. So he seldom, while doing the analysis, most of the time people don't recommend that CBR test. Unless or until there is classified highway construction project thing. So you normally you will get within for instance area town, for instance any town, uh, you will only have this value. Now this is a perfect way, So once you know your, actually this is in imperial unit, that's PSI. So what need to know to convert your ton square feet value to pound square inch value. And for instance, if it is 10, so just for the 10, you will know your value. 10, you just draw perpendicular, and you will find that if it is 10 per 10 psi value, again you have converted it from this 10 square feet value, you find that this is CBR 4. And for if it is your value is 20, then it's 10. So based on this chart, you can always extrapolate the CBR value. Again, I always say it is nothing can replace the actual value. But again, this have been, these charts have been is present in the standard book that I have made. It's present in most of the books. So it's a very much referred chart and very much acceptable to the public. So if even if you use it and you come up with some other value, most of the time I feel that you will have a conservative value. The conservative is no problem. The problem is under design the problem. So if you have this value again, if you don't know CBR value, what you do? If someone has not tested the 10 square feet value, because most of the time, again, this is a practice in our industry that people don't even do this test. They assume, oh, previously I have designed foundation say 0.5 ton per square feet. Every time you will feel me, I am talking about 0.5 ton per square feet. Because people have assumed in Karachi it's 0.5 ton per square feet is the normal way. So based on their assumptions, even though they don't do the test, they have come up with this value. So what I think that even what you can do was simply is to take that soil, maybe 1 kg soil or 2 kg soil, do the sieve analysis, the strictness of all the test. Now, once you do the sieve analysis test, you get plasticity index value of the fine grade soil and thing. You always get this soil classification. And with oil soil classification, you can know the CBR value. For instance, what I'm saying. If I come up with this A4 soil, and if I draw the perpendicular, it is 3. And if I have this again, this A4 soil, this is between 3 to 25. But you see, the previous table, it was also giving that A4 soil is a very good soil. So even people have come up with this value. Two things you can do. Either take the average between the limit, take 3 and 25. But again, if you are an engineer, if you have to be a transportation engineer, you are very careful about statistics. This is very steep values. The standard deviation is very much. But again, you have this thing, you can take this. But logically it doesn't sound. One is 3, the other is 25. So, but again, you can have this. But you can at least have a range. So you is using this chart. You see if it is you have soil classification. If this you have say MR soil, ML soil, this is between 4 to 8. So this is how even if you don't do CBR test, even you don't have any other test, you can easily find the value. Estimate the subgrade. Then comes another thing. And it's very important that you must use this again. Generally along a road are built in kilometers and kilometers and kilometers. So to testing a soil at one point is not good. You have to have soil tests at along the different stations. And then you draw. And from that graph, you will find the best representative value of CBR. Conventionally, we take around 10 locations or 8 locations to perform this. You know, though the specifications are very different. What does the specification say? First test, you are saying doing a 10 kilometer. First test pit will be your at zero station. And then other test pit is 100. Take calculate the value between 0 100 meter, classify the soil, and if you will, there is no much difference. Now you can come from 100 to 1000. Just to take it with the logarithmic scale. And you find that 0, 100, and 12,000 good. They are same. Then just keep on having only 8 or 10 tests. You can have 2,000, 5,000, 10,000. Take 10 or 7, 15, the present rate. The problem arises, the value at 0 at 100 are same, but 100 and 1000 is not same. You can have different soil strata. What you can do? Then you have to have this between 100 to 1000, you have to have one more test. Because the value of 100 and 1000 was there, is not mentioned. Again, you cannot, do it, but sometimes the representative you do, and you take some 10 around 10 values, safer side, you find this value. So, it depends upon the type of road, how important it is. So if just have local road around 10,000 liters, you will discuss this again one more time. If it is up to 1 million more, you will have this design 75 value, the 5 percentile value, or more than 1 million, 87.5. Let's see what I mean and how you apply these relations. Where. For example, you have conducted the test on 8 test pits, and they have different resonant bodies. It can be like that you have different CBR values. Then you have used that 2555 CBR point. Or what you can do is very other simple as well. Take the CBR value, take the represented value, and then you convert to MR. Or if you have this MR value, that's nothing like it. So don't get confused that you don't have to convert each CBR value into MR and down the draw graph. It won't make any difference. Take this design value and convert it to MR. Or otherwise like this. So what you do, then this is about this is what you do. First you do it in the in ascending order. And in ascending order, you see actually this is a standard value, right? So this 42.8, we draw one column and we say 42.8 there are values, there are actually 8 values that is equal to 42.8 or more. When I come to 53.8, there are 7 values that are bigger or equal to this value. When I come to 60.7, I mean there are actually 6 values that equals this value. And then you take the proportion and you will find this cumulative graph that is going all the way down. And once you do it, then on y-axis there is a percentage, the x-axis there is an MR value. From that, on that in the best fit graph, you draw perpendicular for 60 percentile, 75 percentile or 87.5%, and whatever is the value is your design value. Now that value you will take in the pavement design for your pavement design. Now this concludes our our discussion on testing the soil for flexible pavement. For rigid pavement, you do another test that is called the modulus of subgrade reaction test. We'll discuss in the next lecture. So I stop here.